The definition of the intermediate value theorem is for continuous functions on some interval from a to b, the function takes on every value between f of a and f of b. What this means is that a function f of x from an x value of a to an x value of b will hit all of the y values in between those of a and b. For example, in this graph, there are 2 points, a, f of a, and b, f of b. The intermediate value theorem states that all y values between f of a and f of b exist. So if f of a was -5 and f of b was 3, there must be a point where f of x equals every value in between. This could be -2 or 0, for example. This is modeled by the dashed line here. Also, it is possible to have f of x values outside of f of a and f of b, but you cannot prove that they exist. The definition of the extreme value theorem is, if f is continuous on the closed interval from a to b, then f has a maximum and minimum on the same interval. This means that on a closed interval there is always an absolute maximum or minimum. In this first example, the function is not on a closed interval, and there is only one point where f prime of x is equal to 0, which is at 0, 0, which is the absolute minimum. However, there is no maximum because there are no endpoints, and there is no other point where f prime of x is equal to 0. In the second example, the function meets all the criteria of the extreme value theorem, so both endpoints and points where f prime of x is equal to 0 are considered for maximums and minimums. So this is the same function, but there are endpoints here which allow us to have an absolute maximum or minimum, which if we calculate that using the derivative, then we are able to find the absolute maximum is 2, 4, and the minimum is 0, 0. In the third example, the interval is not closed, and f prime of x is not equal to 0 at any point, so there are no possible maximums or minimums. So because the point 0, where x equals 0, is not included in the function under this open interval, then there is no possible maximum or minimum because there are no endpoints, and the one point where f prime of x is equal to 0 does not exist in this particular interval.
The mean value theorem states that if y equals f of x is continuous at every point of the closed interval a to b and differentiable at every point on its interval a to b, then there is at least one point c in a to b at which f prime of c is equal to f of b minus f of a over b minus a. In other words, the average slope on an interval of a continuous and differentiable function would be equal to the derivative of one of the points on the interval. So f of b minus f of a over b minus a represents the slope from a to b because it's similar to doing y2 minus y1 over x2 minus x1 to find the slope between 2 points. So this tells us that if we draw a line from a to b, it would have the same slope as one of the tangent lines of the interval. So we can see what this looks like on this graph down here. So we have a here and b here, and then we drew a line between them. And then on one of the points on this interval, we have a tangent line that is parallel to a to b because the average slope from a to b is equal to the derivative at this point c. An example of a problem that you would do to use the mean value theorem. So this is a problem from the 2007 AP Calculus exam, which says, let f be a twice differentiable function such that f of 2 equals 5 and f of 5 equals 2. Explain why there must be a value c for 2 is less than c is less than 5 such that f prime of c equals -1. So we know that the mean value theorem states that f prime of c is equal to f of b minus f of a over b minus a. So the interval on this function is from 2 to 5, so we can say that a would equal 2 and b would equal 5. And we know that we have the points 2, 5, and 5, 2. So now we're going to plug these numbers in. So f prime of c would equal f of b. So f of b would be 2, and f of a would be 5 over b minus a. So we know b is 5, and a is 2. So then we have negative 3 over 3, which is equal to negative 1. So we see that f prime of c is equal to negative 1 on this interval using the mean value theorem.